to do these preview exercises together because this is a preview not just of today's lesson, but of several of upcoming lessons of some important concepts. So I think it'll be helpful to have reviewed this in our upcoming classes. So I've got two sets of ordered pairs. So set 1 has 2 points in it, 1, 5 and 2, 5. And set 2 has 2 points, 5, 1 and 5, 2. All right, in which set is each x coordinate paired with only one y coordinate? 1, yeah, set 1. Because each x, an x value of 1 has a y value of 5, and 1 never has any other y value, right? And then 2 goes to a y value of 5, but 2 never goes to any other y value. But in set 2, you have the x value of 5 gets paired with 2 different y values. First, 5 gets paired with 1, then 5 gets paired with 2. So my x coordinate of 5 actually gets paired with 2 different y coordinates. Okay, so set 1 is the one where we have each x is paired with only one y. So this is an important preview of what the idea of a function. Definition of a function, and we're going to talk about that a little bit more today, what a function is. All right, so number 2, we're supposed to graph y equals 2x and y equals 2x plus 4. I gave you some xy charts to help you if you couldn't remember how to graph a line. Y equals 2x, so that's y1, so we just double these, 0, 2, 4, and I'll plot. I really only need 2 points to draw a line, -2, -4, and 0, 0, and I'll connect those. And then maybe I'll do one more. So this is y equals 2x. And then for y2, that's 2x plus 4. So I double the x coordinate and add 4. So I'm going to get 0, 2, 4, 6, 8. So I plot those and I get -2, 0. Maybe 0, 4, and one more, 1, 6. Connect those. Okay. What do you notice about those two lines? They're parallel. And how far apart are they? 4, yeah. Is that a coincidence that it's 2x and 2x plus 4 and the points are always 4 units apart? No. So this is a preview of a topic that we're going to talk about in a couple of days called transformations. And that's going to be a big topic. We're going to spend 3 days on it, and you're going to have a project on it. So that's just a little preview of things to come there. All right. Here we've got a graph of a function that looks kind of like a V. What is the y coordinate when the x coordinate is 2 on this graph? 3. Yeah, so that is 2, what is a point on the graph? So you go over 2, you go up to the graph, and you say, oh, 2, 3 is a point on my graph. So if I give you an x coordinate, there's typically only one y coordinate that you can give me back. But if I give you y coordinates, if I ask you for when the y coordinate is 4, what are the x coordinates? There's actually 2 points on the graph, right, that have a y coordinate of 4. We've got one right here. That point has a y coordinate of 4, and so does that point. So we have -3, 4, and 3, 4 are points on the graph. All right, and if I was going to use interval notation to describe all the x coordinates of points on this graph, all the x, so there's an infinite number of points on this graph, right? What is the very smallest x coordinate of any point on this graph? -infinity, because this graph points to the left forever, right? So my leftmost x coordinate would be -infinity. What's my rightmost point? also infinity because that arrow also goes to the right forever. Okay. This is what we call the domain. Right? We'll talk about domain a little more today. Right? But the domain is the set of all x coordinates in a graph or a set of ordered pairs. Okay. What if I wanted to describe the set of all y coordinates of points on this graph? What is the very smallest y coordinate? 1, yeah, so y coordinates are up and down, right? So the very smallest y coordinate is 1 here. So I'm going to start with 1. And what's the biggest y coordinate? Infinity, because those arrows point up forever. So I have 1 comma infinity. Never include infinities. Should I include the 1? Yes, because that point is actually on the graph. So 1 is a y coordinate on the graph. We call this interval, when you're describing all the y coordinates of a graph or a set of ordered pairs, we call that the range. And we'll define those two words a little bit more specifically in the lesson. Okay, so first we're going to talk about relations. Graphing, interpreting, and modeling the relationships between two variables or two sets of data is an important goal in this course. In our earlier work with graphing, we learned that two sets of data can be represented as an ordered pair, x comma y. So for example, say we take David Lee, Avery Bradley, Jared Sullinger, and Isaiah Thomas from the 2015-2016 Boston Celtics team roster, and we list their heights, 6'9", 6'2", 6'9", and 5'9", respectively. You can write the correspondence between name and height as a set of ordered pairs. So you just write each name down first. Next to that name, you put the height. So David Lee, 6'9", Avery Bradley, 6'2", Jared Sullinger, 6'9", Isaiah Thomas, 5'9". So the set of ordered pairs, any set of ordered pairs, whether it's got numbers or names or whatever, any set of ordered pairs is called a relation in mathematics. Okay? Relation is any set of ordered pairs. Doesn't have to be numbers. And we could describe them using a map, right? So the set of names is the set of all first components or inputs of those ordered pairs. And we call the set of all inputs, the set of all first components, we call that the domain of the relation. And then the set of heights in this case, this is the set of all second components or outputs of the ordered pairs, and it's called the range. And notice that I only listed 6'9" once, right? Because when we first learned about sets, if something shows up in a set more than once, it doesn't matter. You only write it once. So then we could make a little map where we list all the elements from the domain in one circle, all the elements from the range in another, and then we map names to heights, right? So Avery gets mapped to 6'2", and David gets mapped to 6'9", Isaiah gets mapped to 5'9", and Jared also gets mapped to 6'9". So we listed the name of the Celtics player first and their heights second. That was a decision that we made here. But we could also represent a relation by switching it, right? We could list heights first and then names. So if I was going to fill in the domain and range this time, my domain is always my first component. So my domain now is going to be 6'9", 6'2", and 5'9". And my range is the names, the second components of the ordered pairs. David, Avery, Isaiah, and Jared. Okay. And then we can map them, right? So 6'9" gets mapped to which player or players? David and Jared. So I put an arrow to David and an arrow to Jared. Okay, 6'2" gets mapped to Avery, and 5'9" gets mapped to Isaiah. Good. All right, now suppose we're giving out the MVP award, and it's announced in front of, millions of fans. I don't know how many fit in the garden, right? that the MVP award is going to go to the player that is 6 feet 9 inches. Who gets the award? Yeah, it's either David or Jared based on what we know here. Yeah. It could be a lot of other players too. Yeah. There's no way to tell who would get the MVP award if we just list the height of the person who gets it, right? So when we list height and then name for this particular relation, we say that this is not well defined, right? We like to be able to look something up in the domain and have it mapped to exactly one place in the range. Okay. So in this case, not well defined. Okay. So our work in this course is going to focus mostly on well-defined relations, and we name those things functions. A function is just a well-defined relation, which means that there is exactly one output value for any input value. Okay. So for each element in the domain, there is one and only one corresponding element in the range. So for our basketball example, we have two relations, one where we list name, comma, height, one where we list height, comma, name. Which of those sets, P or H, is a function? Which one is well defined? Each first input corresponds to exactly one second output. P, yeah. It's not, H we decided was not well defined because of this MVP question, right? Where if you list height first, if I say 6'9", you can't figure out who I'm talking about, right? So, but if I say the name first, I can look up their height. It's unequivocal, right? So think of it as like a database. If you want to look up 6'9", you're going to get at least 2 players who have that height, and that's not very helpful, right? But if you look up a name, you're going to get 1 height. One person can't be more than 1 height. Yes? In this case, we don't. Yeah, in this case, we don't. That was a good question. 2 people with the same name. We would have to adjust our definition, like we could use social security number or something to make sure it's well defined. Anna. That is a great question. Great question. So if we go back to our first, the first way we defined it, where we look at the names as the domain and the heights as the range, what makes it well defined is that each name has 1 height, right? It doesn't matter that there are 2 names that go to the same height. Just think of it as if I give you a name from the domain, can you tell me their height unequivocally, right? Like, so if I say, David, what's his height? 6'9". It's easy to answer, right? But in the other one, if I pick a height, 6'9", who's that height? You're like, oh, well, it could be David, it could be Jared. It's hard to answer that question. So this is the one that's well defined. Okay. I like to think of a function as a machine that works well, right? So let me just label this. This one's a function. And I will come back to a function as a machine analogy many times for the rest of the semester. But think of it like your television, right? There are inputs, there are numbers you press on the remote, right? Those are your inputs. And then the output is what pops up on your screen, okay? Whatever station you put in. So like when I am at my house, if I type in 7 in my remote, NBC comes up on my TV, right? Every time. It's never like sometimes I put in 7 and I get NBC, and sometimes I put in 7 and I get, I don't know, Lifetime, right? So a function is like a machine that works correctly. You have an input, it always gives you the same output. Okay. But also on my TV, if you have like HD channels, right, there might be 2 numbers that get you NBC, right? If you put in 7, you get NBC. If you put in 807, you also get NBC. That doesn't mean my TV's broken, right? I'm not going to call the cable company and be like, I have 2 NBCs, this is a big problem, right? It's not, that's okay, right? So one input can have only one output. If you have 2 different inputs that give you the same output, that's okay. Right? The only time you would actually call and complain is if you put in 7 and sometimes it gives you one station and sometimes it gives you another. Okay. Okay, so there's some notation associated with functions. So here we've got a table. It lists the height of a basketball, y, in feet at various times after x seconds. Okay, so the values listed define a function, right? If x is your input, y is your output, this is a function because at any given time, the height of the basketball can only be in one place, right? You can't say, oh, at 5 seconds, the basketball is at 3 feet, and at 5 feet, it's only one basketball, right? So this is a function, and we say that y is a function of x. Y depends on x, right? That's what how we use the word function in the English language. That's kind of why we use the word function here. Y is a function of x because y depends on x. Typically, instead of using the variable y to represent a function, which you have done for a couple of math classes now, right? We use letters such as f, because f stands for function, and then g and h, because they're the 2 letters that come after f, right? And then capital F, G, and H, right? Sometimes we use other letters, but F, G, and H are the most common. And we represent the function above, this basketball height function, as y equals f parentheses x. So this is brand new notation, and you would read it, y is a function of x, right? So these 2 are equivalent, right? So you read y equals parentheses f parentheses x, you read that as y is a function of x, or y depends on x. Really important, this f parentheses x does not mean multiplication, right? So it's really important to keep that in mind and not confuse yourself and think that it means multiplication. You read this f parentheses x as f of x or function of x. The input is x and the output is f of x. So f of x, this f parentheses x, we just used to call this y. Right? Used to be called y. So instead of y, now we call this f of x. That's it. It's just a new way of writing y. Okay. Typically, we write f of an input equals an output. All right, so I think if we do some examples where we work with this notation, it will get a little clearer. Right. So we're going to use this basketball, the table that gives the height of the basketball as a function of time, to evaluate f parentheses 2. You would read this as f of 2. And this is asking us to find the output, which is the height of the basketball, when the input time is 2 seconds. So the number in parentheses is always an input. Okay. And if I want to know f of 2, it's asking for the height when time is 2. So what is it? Yes, according to this table, when time is 2, height is 99. Okay. Okay, and if I want to interpret that, I would say the height of the bat after 2 seconds the height of the ball is 99 feet. I think we were measuring in feet. All right, what's f of 0? 3. Yeah. So that's just because that 0 is in parentheses, you know it's an input, it's a time. So we go to the table, we look up x equals 0, and we get 3. 3. So what does that tell us? The initial height of the ball is 3 when we started tracking its height. Yeah. The ball is 3 feet. Good. All right, what if I ask f of what number gives me 103? So now I'm asking you to tell me a time that the height is 103 feet. 2.5? Let's see, go back up and look. Find 103, happens at 2.5 seconds. Good. Okay, so in this case, I would write as a solution to this equation, x equals 2.5. And then to interpret it, I would say the height reaches 103 feet after 2.5 seconds. No. It doesn't matter as long as you have the units correct, yes. As long as you know which number represents what. Good question. All right, so I know that it's a little bit overwhelming. The notation of functions can be a little bit overwhelming, but you have an opportunity to practice now, and I will come around and help if you are confused.